Hi, and welcome to this week's episode of the Structural Engineering Podcast with Max and Zach. This week, we discuss precast concrete design with Nathan Krause. Nathan is located in the Midwest region of the United States and brings great insight to the world of precast concrete. Although we are coming to the end of Season 2 of the Structural Engineering Podcast, we plan to bring additional future episodes on precast concrete to discuss detailing and high seismic design. Now, let's start the episode.
This is Nathan Krause. I work for Kirkstra Precast. We're a precast concrete manufacturer and engineering firm.
Thanks so much for being on the show.
Yeah, thanks for having me.
All right. So the first question that we wanted to get into, starting with the basics, what is precast? And for someone that isn't aware of it, where would they be most likely to?
So precast is concrete pieces that are made on an offsite location and then shipped to the construction site where it's being built. So you'd most likely see it parking structures, but it can really be used for any building type. So warehouses, schools, churches, pretty much anything like that.
Are most precast plants local? How far is it reasonable to ship?
It's pretty common to ship within like a 300-mile radius. So we're in Grand Rapids, Michigan, and we frequently ship to Detroit, which is on the other side of the state. But we also get into Ohio, Indiana, Illinois, the Chicago market. I mean, I think the furthest we've gone is Colorado.
Jeez, that's a stretch.
That's definitely pushing it.
How do you specify precast on a project?
So the first thing that you can do to make sure you're in the ballpark for a design is there's any precaster that you'll come across will have load tables on their website that you can download. Otherwise, there's an online resources that you can use from the PCI, the Precast Concrete Industry. If you know the general idea that you want, so you want to span a floor, 30 feet, you can go on the website, find those load tables, and you can use those load tables to figure out what shape that you want. So for instance, 10-inch hollow core, and you can specify that on your drawings. But the other things that you'll need to have on the drawings are obviously the loads that you're using and any openings or special considerations that need to be in there. And then the engineering team, the precast engineer, can take that information off the structural drawings, and they create the precast specialty drawings, the shop tickets.
Cool. Does every precaster make basically the same selection of structural components?
Similar. It does vary from precaster to precaster. In general, it's pretty similar.
Is that mostly based on the setup that precaster has?
Yeah. And, we're up in Michigan, so we have higher snow loads. So our sections might be a little deeper than somewhere down in Texas.
Cool. That makes sense. What is the EOR responsible for? And then what is the precaster specifically responsible for when you're, coordinating this design?
So the EOR is responsible for specifying the loads, telling the precast engineer what the design criteria is. And, that could range. I had a project where we were a cover for a pump tank. And for whatever reason, in the specifications, it said that the system must remain in compression at all times, which is pretty unusual. But we were able to pre-stress it enough to make sure that there would never be any tension in the slab.
I wonder if there's just environmental reasons there.
Right. Yeah. So the design criteria, any governing codes, make sure to specify what the precaster is supplying. Are the walls cast in place or are they precast? The size and location of blockouts. And a lot of times that's a coordination between the precast and the mechanical.
I'm curious, besides the gravity, which I think is, would feel like the clear thing to put on there, when you're looking at lateral or if you have a precast shear wall, is that all conveyed in the exact same way? You just put on here's my load into this precast shear wall, and the connections between precast would still be all you guys?
That's right.
Oh, cool. That's so easy.
Technically, 11 things that technically the EOR is responsible for. All structural design criteria, governing codes, items furnished by the producer, which would be the precaster, the size, location, and function of all the openings, blockouts, and cast-in items for other trades, detailing requirements for the other trades, including connections and reinforcing. So that would be, for instance, if electrical was supposed to be cast into the precast, or there was a light pole that on top of a parking structure. Tolerances for if we're butting up against an existing building, how big of a expansion joint should we put in the building? The last big one, which is I find it a lot of times it's on the architectural drawings, but the fire resistance requirements.
Oh yeah, totally.
Because obviously we would have to know where to place how close to the bottom we can put our strands.
How often do you get a set of drawings from the EOR that specifies sizes that actually don't work?
It happens. It's not frequent. A lot of times it's actually moving more and more towards this, where we get a set of maybe permit drawings or progress drawings, and we can go work with you guys on the front end to make sure that the sizes work. But obviously if we get a project that's complete set of drawings, and we find something that might be an issue, what we would do is we just send a RFI. The bigger one that happens is the design team is working with one precaster in the area, but when the project gets kicked off, that producer is too busy. And so a different producer will get it, and they have slightly different forms. So they might have to change the size a little bit.
So can you make a whole building out of precast?
Yes, it's actually what we prefer to do because we get a larger chunk of the pie, but you'll find a lot of parking structures made of precast completely. Warehouses, you have the walls, precast walls with precast roof, maybe double T's or hollow core. You get some beams and columns in there.
What's the largest you can reasonably ship? And I'm thinking of this from like the precast side, right? We're basically pour to something that we can lift easily enough. Dimensionally and then weight-wise, what's a decent thing to get on a truck?
Right. So in Michigan, we have higher limitations on our roads that we can, we can put more weight on our roads. So it's really limited by our plant on what it can pick. So in our plant, we can pick something that's 80,000 pounds. And then as far as shipping goes, it can be up to 12 foot wide. But if you're going across a bridge, so for instance, if you're going from the lower peninsula of Michigan to the upper peninsula, the widest that can be is 8 foot wide. And then when we do get something really large, like a 16-foot wide double T, we would actually tilt it at a angle, like 45-degree angle. And then that way, as far as the road is concerned, you're not taking up 2 lanes.
Jeez.
But there's special permits that the precaster has to look into and make sure that what they're shipping can actually go down the road.
On the same line of, can you make the whole building out of precast? I've seen a couple times, I don't know if I've necessarily seen this in the United States, but definitely overseas. Have you guys ever done precast foundations?
I have never done precast foundations. I don't think there's anything special about, whether or not you can do them. It's just a cost in your area.
Do you guys do precast basement walls? I'd also heard of that as a thing, like for residential.
Yeah, I did some precast basement walls for an underground basketball court.
Whoa, cool.
The walls, I think, were 30 feet tall. And so there was all that soil behind.
Yeah.
There. It was actually a situation like you were mentioning before, where the size called out didn't actually work initially, because the thought process was, there's a retaining wall system that's going to be in place, so the walls are just going to be there, essentially, not taking any soil load. But then it was, the retaining wall was just temporary. It was made of wood, and so eventually that was going to break down, and the precast was going to have to take the soil load. So we had to make the walls a lot thicker, and it was quite an interesting design project.
I'm curious, if this was cast in place, I had some image in my head of this would be a very, very thick wall. Being pre-stressed, do you remember how thick this was? Just for some relative advantage?
It was 16 inches thick, and the reason was we have all of our pieces separately. So I designed the wall as a pin-to-pin connection. Whereas I think a lot of times when you guys are basement walls, you might design it as a cantilevered wall.
Yeah, definitely. If it's doing some serious retaining. Wow, that's pretty. But if it was cast in place, that would be massive. So 16 doesn't sound that bad.
So what are the precast structural shapes available to us? And what are really the most common ones used here in the United States?
So columns, beams, walls, whether they're solid walls or insulated walls, double T floors, hollow core floors, or just a precast solid slab. Then you'll also get into the more unique shapes, so stairs or stadia risers.
How do you make hollow core? This is a silly question, but I can't. Do you inflate a balloon inside and pop it like paper mache?
That's actually how it used to be made, where they would take tubes and fill them up and then pour wet concrete in there. But nowadays, the majority of hollow core is made out of an extruded machine. Okay, so for when you're producing hollow core nowadays, we use a dry cast system. So the concrete gets...
How is hollow core produced? Might be a little confusing for people that don't know what hollow core is in general. So what if we just started with, what's hollow core?
So hollow core is a solid slab with voids in the middle. So usually there's anywhere between 4 and 6 voids per a 4-foot section. So it's 4 foot wide. So hollow core is produced by taking a dry cast mix and putting it into a machine, and the machine compresses the concrete, and it actually looks like you're squeezing out a tube of toothpaste, if you can envision that.
Oh.
And so we produce those in lengths up to 140 feet, and then they're cut to size for a specific project. So, the size of span for hollow core is usually between 20 and 40 feet. It can get up to 60.
And is the hollow core something that is pre-tensioned?
Yeah, so we have pre-stressed strands, so anywhere between a 1/2-inch strand that has 30 kips of force in it and a 0.6 strand which has roughly 41 kips. And there's, again, anywhere between 4 and 12 strands in a single 4-foot slab. And
sweet.
All the slabs all the strands are concentrated in the eye portion. Like if you picture an I-beam, a steel I-beam, essentially what hollow core is a lot of I-beams that are stacked side by side next to each other.
Oh, that makes sense. For the concrete of this stuff, like what does the slump look like, or the water cement ratio? Are these really dry mixes?
Yeah, so the water cement ratio that we run is 0.13.
Wow.
So we have lots of high range water reducer that we add to the mixes. And literally after the machine compresses it, you can literally walk on top of it as it's coming out of the mix.
So, and that's like more or less a quarter of the water you might see in some like traditional cast in place mixes. Are all the mixes lighter on water in most precast assemblies with a double T or whatever?
Yeah, just because we need to meet a strength really soon, we turn our beds in a 12-hour span most of the time. So we'll produce one day with, putting the rebar and pouring the concrete in there. And then overnight it cures, and really early, like maybe 4 a.m. in the morning, we'll come in, strip the piece, remove it from the form, and then start that process all over again. So we really have to meet our early concrete strength.
Yeah, absolutely. On that, do you have to control the temperature at all of the cure so that it's not too hot with all the cement in there? Or is it just at night it's fairly cool and it's not a big deal?
So we produce all of our products indoors. And so we don't have to worry about the sun beating down on it. But if you are a producer that's producing outside in maybe some of the southern states, they might have to create temporary, tents just to... Or maybe pump cold water through the forms just to make sure that they don't get too hot.
Cool.
Now, something I've heard is that you can camber precast elements. Is that something that is done just with hollow core, or is that something you can do with, or that is typically done with all precast?
Anytime a precast floor system has pre-stressed strand in it, you're going to get camber. So we put all of our strands towards the bottom of the member, and all that force compresses the concrete on the bottom, and you get tension in the top. That stress combination is what causes camber. So for hollow core with double T's is typically where you see your camber, and that needs to be thought about when you're designing the building, because if you're pouring, if maybe you're putting a topping on the hollow core or the double T's, you might envision that there's 3 inches of composite topping, but maybe in the center there's only 2 inches.
When you camber, so like for people that are familiar with cambering a steel beam, it's some percentage of the dead load, something like 80%. Is the camber on a double T or a hollow core related to the dead load, and that some will come out and maybe relaxation of the strand, some more will come out? Is there some balance there?
It's more related on the length because obviously the longer the member is, the more strands you put into it. So for something that's, between 20 and 30 feet, I would expect an inch of camber. But when you're getting into a 60-foot long double T, it might get up to 3 inches of camber.
And that'll be there forever.
So when you put a topping on, a little bit of that comes out, and when you put in all your furniture and everything like that, a little more comes out. Obviously, the more dead load you put, the more it's going to get taken out. But in general, it's going to be there. Yeah.
Okay, cool. So on the composite topping, something that's always been I don't totally understand, I guess. When is the topping slab structural? When is it sort of a diaphragm? I guess you just tell me about how that works.
So as long as there's not a barrier between the cast in place topping and the precast element, chances are you're going to get a composite topping. There's things that we can do to the precast to increase the bond. We can rake the concrete on top to ensure that you get the 1/2 inch amplitude that ACI specifies. In beams, you don't have a large surface area, so you don't have that same surface friction that you might get for a double T. On beams, what we'll do is we'll project rebar out of the top to engage that composite section.
Yeah, I've seen that on bridges, I guess.
Same idea for buildings.
Is the topping slab going to be reinforced just like the same? Like you said, on a high camber, you might get down to a thinner topping slab. So not maybe the cover that you might want, I guess.
Right.
You would just reinforce that like a normal slab.
So the topping slab would be something that the EOR would design, but a lot of times you'd see mesh, mostly for crack control and shrinkage.
Yeah,
is usually what it's used for. For parking structures, that you're driving your trucks on and cars. Mm-hmm. A lot of times the precast alone, if you have a precast double T, it has a stem and then it has flanges that hang over. The flange design is usually what is limiting factor for the amount of point load that you can put on. When you have that cantilever of the flange with the wheel load on it, all you're reinforcing in the precast is on the bottom. Where you want it to be is in the topping. So sometimes the precaster will request or specify, a minimum amount of steel that they need in the topping to account for that transverse bending.
Okay, so if you have a topping slab, and let's say we're in a parking structure or something like that, right? Mm-hmm. Do you get reflective cracking between the kind of more flexible precast double T and then the topping slab, or do you purposefully stop that topping slab at the edges of your double T?
If you didn't do anything, you would get cracking at the different members. What we recommend is that between your beam and your double T, that there's a control joint that's put in the topping.
So, something I've also heard with parking garages specifically is that topping slab is typically used as more of a wearing surface in a way to sometimes there's barriers between the topping surface and the double T's to make sure water intrusion and chemicals and stuff aren't eating away at your structure. Is that true or is that a myth?
That's true. That a lot of times the topping is used for a wear surface. It's also a great place to put diaphragm steel if you're in a high seismic area. Cast in place is awesome for hiding that diaphragm steel because in the precast world, we have individual pieces that we have to connect together, which we can connect them together for seismic loads, but sometimes it's just much easier to put that in a topping slab.
Do you guys only do new construction, or do you ever get hired to retrofit existing precast?
We don't get into the retrofitting business, but there are other companies that do retrofitting. And the awesome thing about precast is since it's individual pieces, if you're wanting to change the shape of your building, if you have the budget for it, you can actually remove some pieces or add on. It's really easy to add on to precast.
And you would just if you needed to then tie those things together, you could just put in some, not embed plates, but anchor in some new plates.
That's right.
Your corners. Wow. Okay.
Or again, if you want to add an opening to the precast, if you want, you can remove the wall, assuming that the wall is embracing other things or being used as a shear wall.
So what would you say is the biggest mistakes that you see that the engineer of record's doing that we as an industry could learn to help the whole project?
The biggest mistake I see is not accounting for tolerances in the drawing. So if you're butting up next to an existing building and you're showing from this this grid line to the end of the precast, you want it to be 2 inches, whatever it is. We don't live in a perfect world, so we're not going to produce all of our pieces perfectly. We have tolerances. We could easily produce a piece of hollow core that's a 1/2 inch too long. If you don't account for that amount of tolerance, pieces aren't going to fit up.
What's the basically capacity for like field repairs and stuff? Is that kind of just not going to happen?
No, there's room for field repairs. If there's a piece that's too long, it can get cut in the field. If a piece is too short, you don't have as many options because there's not a concrete stretching machine invented yet. You guys should work on that though.
Concrete welding.
But a lot of times, something can be epoxied. If there's a plate that's off location, it can be epoxied in or bolted into a panel.
Okay, that's not bad. And like cutting new holes, as long as you miss tendons, not a huge deal sometimes. I mean, it would have to be looked at, but it's doable.
It's very doable. It happens all the time.
All right.
Yeah.
Those dang mechanical engineers, that's all I can say.
I know, right?
I know. You guys did a whole podcast on that.
Yeah.
Yeah.
Still haven't figured it out.
We still don't get how they think. It's like you have a nice shaded wall. That's your shear wall element on your project. And they're like, hole, hole, hole. It's like they just pick out the greatest walls. They think we hatch them for them. But those selfish mechanical engineers.
A lot of times what we'll do is if we know that there's going to be a lot of coring on a project, for instance, for hollow core, we'll put the cross section of our hollow core pieces on our drawings. And then we'll say from the end of this piece to the right, 3 inches, there's going to be a strand. And then another 9 inches, there's going to be another strand, and so far and so far. And then the electrical person can come out there and measure and make sure that they're not hitting a strand. And then occasionally what will happen is they'll start coring and they might hit a strand because their measurement was off location. And as long as it's one strand, we can usually work with them. There might be distribute some load. But I had a project where I got a call and a picture on my hollow core. It was all grouted in, luckily, but they went through and they cored every maybe 6 inches or so. And in the picture, you could see right where the hole is, the strand was cut and all the pieces. It's like, man, after the first one, you think you would have stopped.
Yeah.
So when you're doing hollow core and there's openings that need to be in it for any sort of reasons of mechanical or plumbing, do you guys, obviously you can't put in the holes in your machine, right? So do you cut in holes into the panels after the fact?
So in our wall panels, we cast in opening wood blockouts. We can do it of any size, and actually we prefer to cast in the openings as long as they're reasonably large opening, because then we can reinforce around the openings to make sure that large cracks or anything like that. We can strategically place our strand to miss the openings and add any additional reinforcing we need around it and design it ahead of time. So that's our preference. If there's going to be large openings that are cast in after the fact, we had projects where they wanted to add a few windows or a man door a few years later. We can definitely look at that and see, we might have to shift the door a few feet just so we have the same amount of rebar in there, but we can definitely look at that. For small openings, like mechanical, maybe pipes, a lot of times, anytime they're under like 10 inches by 10 inches, there's just too many of them for us to cast to our products. So then those can be cored on site as long as, again, they miss the strand.
For field repairs, if they do hit a strand, will you guys look at fiberglass, carbon fiber, like bolt-on steel or something? Will you assist with the repair, or do you say, sorry, what do you think, EOR? What do you want?
Yeah, so we'll work with the EOR to come up with a solution. A lot of times can do, if it's in hollow core, we can drop in a header and just support that to plank locally and then distribute the loads to the adjacent piece of hollow core. But if your system is really heavily loaded and the precast is being pushed to the max, might have to look at a beam and column being added just as a support. But like you said, another option is the carbon fiber. I gotten too deep into that, but that's definitely an option.
You work for a precaster as the engineer designing the panels or designing the double T's or the precast beams. Do you at all involve yourself in helping them develop the pricing for the project? Are you on that side of it as well?
I'm not, but we have engineers at our company that's their whole job, is that they work with our estimators to come up with the pricing, and they're able to catch some of those early issues. If a beam is not deep enough, or there's a special point load that won't work with hollow core just because it's 30,000 pounds, so that they can catch some of those potential issues.
Very cool.
For people that might get into this industry, that are graduating school, what do you think about it? You've worked in a few different structural fields. Is it fun doing the precast stuff?
I love doing precast. There's always something new. It's not as set in stone as maybe steel construction would be, where there's specific types of connections that you have to use or are best to use. It really changes per project and per area. So it's really cool to be in the precast industry because there's constantly testing new ideas and new configurations. I love being connected to producer also, because if I'm ever wondering how is this made, I can just walk out my door and put on my hard hat and go out there and actually look and talk to the people that are making it.
Yeah, that's pretty cool. I don't think any of us get quite enough field time, so being able to just step out the door and be like, oh, that's how they do it. Cool. Yep. That's pretty nice.
The other thing that I weirdly I like is if there is ever an issue, instead of the guys going to their phone and trying to call someone, they can just walk in and say, hey, I got an issue, where can I move this rebar, or where can I put this embed plate?
Yeah.
It's nice to be able to catch those issues up, before they become it.
Totally. Makes sense.
We really appreciate you taking your time to talk to us about precast, and I think it's been really interesting to learn more about it.
Thanks for having me on.
Hey guys, thanks again for listening to the episode. Let us know if you have any questions by reaching out to us on LinkedIn, Facebook, Instagram, or email. You can also find these links and more information about the specific episode in the show notes below. Have a great week.